Alright, so we have the following circuit. We have to find V1, V2, and V3. So let's write down the directions of current. But first, let's focus on these resistors. So these are Simons. The Simon is equal to 1 over a resistor. So to find the resistor, it's equal to 1 over the Simon. So this one, it'll be 1 over 8. This one, 1 over 2. This one, 1 over 4. This one is just 1 ohm. So let's find the directions of current. Let me draw these more better. There. Actually, let me just find them in decimal point. Alright. And this is the ground node, so it's 0 volts. So let's write the directions of current. I1, I2, I3, I4. Now I5 is tricky because we have this dependent voltage source. So if you have I4 here, we can't find I4 because there's no resistor here. So what we're going to do is we're going to create a super node. So we're going to pretty much combine this into one whole node. So first we have to write an equation to represent this. So if we say that there's a current moving in this direction, then it's V1 minus 2 VO as we're leaving the negative terminal, and then this is equal to V2. Okay? So now let's write a node. It's okay, so now let's combine this and let's write a node equation for V1 and V2. So I1 leaves plus I3. So that's and then I2 and then 2 amps enters. So this is equal to 2 amps. And then let's look at the V2 section now. I2 and I4 also leave. So plus I2 plus I2 plus I4, and this is equal to 2. And yeah, that looks pretty good. Okay. Now let's focus on our node V3. So, oh wait, there should be one more current direction. It's this one. I completely missed this one. Let's call it I5. Okay, so wait a minute. We already know what V3 is going to be equal to, because this V3 will be equal to 13 volts, and the reason is because there's no like resistors or current sources or anything like that, so it won't experience like a voltage drop or anything. So for example, if a current moves in this direction, it's gonna hit 0 volts, and for the only way to hit 0 volts is if this one is 13, because 13 minus 13, because it's leaving from the negative terminal, is equal to 0. Okay, so V3 is actually 13, so that's already one done. All right, so let's find an equation to represent our I values. Okay, so I1 is equal to V1 over 1. So I1 is just V1. I2 is equal to V2 minus 0 all over 0.125, which is just 4V2. I3 is V1 minus 13 all over 0.5, which is just 2V2 minus 13. And then we have I4. It's V2. Oh, sorry. It's I3 is V1 minus 13. I2 is V2 minus 13 all over 0.125. And that's the same thing as 8V2 minus 13. 8 times V2 minus 13. So that looks correct. Now let's work with this. So it's V1 plus I3. So V1 minus 13 plus I2, which is 4V2 plus 8 V2 minus 13. So now let's plug in V2 with this. Oh, by the way, I just realized we have this VO here. So we have to find a way to get rid of that VO, but we already know what VO is going to be equal to. VO is equal to V2. Because, see, V2, as it moves downwards, it experiences a voltage drop of VO, and then it equals to 0. So V2 minus VO has to equal to 0, and that means V2 is equal to VO. So this is V2. Bring it to the other side. This is equal to 3 V2. Divide both sides by that. This is what V2 is equal to, 1 over 3 V1. Okay, so now let's, take care of this more. Minus 2 times 13. Sorry, minus 2 times minus 13, that's minus 26. Plus 4 over 3 V1. Plus 8 over 3 V1. Minus times minus 8 times minus 13. That's minus 104. Let's collect like terms. So 1 plus 2 plus 4 over 3 plus 8 over 3. That's 7v1, and let's collect the other like terms. So minus 26 minus 104. That's minus 130. Let's bring it to the other side because this is equal to 0. So bring it to the other side. So it's equal to 130. Divide both sides by 7. V1 is equal to 18.6 volts. Let's find V2. V2 was equal to 1 over 3 V1. So 1 over 3, 18.6. And that's equal to 6.2 volts. And then we have V3. That's equal to 13 volts. So these are your final answers.